Hello, how are you doing? Welcome to another math lesson with Mr. Woodford. I'm very excited to get into this lesson with you. For those students of mine who are this year, which is 2025, thank you so much for allowing me to work with you and help you through um, these lessons virtually. I know they're not easy, but I'm very proud of you guys, and I pray that you continue to keep the hard work up throughout the 10 year. All the rest of my future students who are watching this video, thank you for your work as well. Continue to keep up the good work. Continue to watch the videos all the way through. Today's lesson is going to be focused on 6.5, which is calculating percent errors. So take out your packet, look with me at the lesson, and let's begin to get into it. So first, as with every lesson, every video, take a moment to pause the video if you need to and work on the bell work. All right. Hopefully you have some time to calculate it. Now I'm going to go quickly through these with you to make sure we have the same answers. There are some equations that we talked about in class, which I will quickly mention also now in this video. There's a formula called 1 plus percent, right? This is us calculating the value of a percent increase as if we were taking the value and multiplying it by 1 plus whatever the percent is. Now, on our calculators, we can easily put this in, but if we don't have a calculator, then you might want to turn that percent into a decimal, okay? The math will look something like this: 499 multiplied by 1 plus, or 1 plus 25% if you was putting it in as 25%, right? So there's one way of doing it like this, and you put that in your calculator. But if you're doing it without a calculator, it would be 1 plus 0.25, okay? And you would end up multiplying here, you would get your answer. And in my case, we would end up with, in our case, sorry, we would end up with an answer of 623.75. Why does it sound wrong? Oh, it sounds wrong because this problem is asking us about decrease, not increase. My apologies. So this is what it looks like. It's a decrease problem, not an increase problem. So this will look something like this. And when you multiply it all out, your final answer will be $374.25. So if you got that correct, excellent job. Remember, decrease is another way of saying discount. All right, discount is another way of saying decrease. If something's on sale, which means that it's going down in value, decrease as well. If it was sales tax, that means it's increasing. If it was a markup, that means it's increasing. So just pay attention to those words. They do matter. For B, you should use the formula of N with times 1 plus percent. This is an increase formula, right? When you're calculating a new value after a value has been increased by a certain amount or a certain percent, right? Which in our situation here, we would take the 20 miles that he's originally running, and we would multiply that by 1 plus, you can type in your calculator 30%. And that's good enough to get you the answer on a calculator. If you're using a calculator but you want to turn the percent into a decimal, you can do it as this as well, and you would end up with your answer, which would be 26 miles. Right? Remember, we are still talking about word problems, which is good to answer with words. So this here will be that there's total the TV cost, right? So we would write since this TV cost $374.25, whereas you could say here he ran 26 miles. Something like that lets us know you comprehend the problem, you understand the concepts, which is good. Okay. Let's take it a little bit further. You ready? Okay, let me just full screen this so that way we can all see it together. Okay. When we look at the modeling, okay, and just to give you an understanding what we're working on percent error. So we would focus on this formula here. Difference equals percent error multiplied by actual. This is a good formula. We are going to use this formula, right? I'm going to show it to you in a little bit of a different or a little bit of an easier way to digest it and handle it. But let's look at the modeling. Sean estimated that the attendance at a college lacrosse game was 3,000 people. The actual attendance was 3,296 people. What are 3,296 people who showed up? What is the percent error of Sean's estimate? round to nearest whole percent. So we want to find this percent error. Now, using the formula above, it says the difference is equal to the percent error, which is what we're looking for. So we can say that's kind of like our variable x multiplied by the actual amount. Now, the way I could teach you is say, okay, calculate the difference, set it equal to a variable x multiplied by the actual amount. And that's not bad. Once you manipulate the one-step equation, you know how to solve it, divide both sides by the number that's next to the variable. You can certainly get it. But if I were to manipulate this equation one step further just to find our answer, I would just automatically divide it by the actual amount. So the formula I want you to actually hold on to is the difference of the values, right? This is all going to be divided by, okay? It's going to be divided by the actual amount, okay? So we're going to take the difference, divide it by the actual amount, and then we're not done. We're actually going to do one step further. We're going to multiply. So I'm just going to draw a dot here. That means multiplication, right? We're going to multiply it by 100. Now, why are we multiplying it by 100? Because we're turning it into a percent, right? So in order to turn it into a percent, we want to multiply it by 100, and that's going to give us our actual answer, okay? This is the same as the formula above. However, it's just written a little bit differently, and I think it's better for us to be able to understand it if it's written like this. All right, so let's do it. First, let's calculate the difference. So when I'm looking at the information they gave me, they told me estimated value is 3,000. They told me actual value, right? And it's very important that we recognize these words. Recognize the words that they're talking about here. They're telling you actual, they're telling you estimated, they're giving you what you need to know. Now, not every word problem is going to say estimated and actual. Some might say miscalculated. They might say they thought. Those words are attached to human error. That's why this problem is called percent error. Where there is an error here that was made. How much was the error? How much percent was this error? So first of all, let's start off by calculating the difference. The difference here would be, just to give you all the numbers, it would be 3,296 minus 3,000. And we would end up putting that all over the actual amount, which the actual amount in this problem, if we look at the actual word problem, you'll see it says the actual tenants was 3,296. So that's going to be all over 3,296, okay? Now, just to start off, so you all know, before you go multiplying by 100, which we will, we are going to multiply by 100. So if you want to put that there as well, just to keep the consistency, that's fine. I'm just going to write this out instead of typing it, okay? We would end up with 296 all over this 3,296. And before you go and multiply by that 100, take a moment to get the decimal. Okay. 296 divided by 3,296. So keep in mind, while I'm doing these calculations, you should also be doing them in your calculator as well to make sure that what I'm doing, you're getting as well. So you can see what I'm doing. So this, keep in mind, a fraction is just really the operation of division. So I do 296 divided by 3,296. That gives me 0. Should I put a little equal sign here? 0.089. Ooh, why did I write my 8 like that? I'm so sorry. 0.0898. Okay, and you should see that as well if you're doing it. And then you would multiply it by 100. Now, when you multiply by 100, it's the same thing as moving the decimal 2 spaces over, and we get 8.98%. Okay, this is our answer. However, for this particular problem, there is one step further. They want it to round to the nearest whole percent. So our actual final answer would be 9%. So the percent error for this problem that Sean, how much was Sean incorrect? He was incorrect about 9%. Okay, that is how we calculate percent error. So once again, you want to remember and hold on to this formula: difference over the actual amount multiplied by 100. If you do this, you should be able to calculate percent error for any of the problems that's in this worksheet. Take a moment to begin to work on your homework, because I know if we're doing a flipped classroom model, you need to work on your homework. If we're doing an in-class model, take a moment to work on your classwork, okay? But nonetheless, I'm looking forward to your work being done and with excellence. Feel free, if you need to watch the video, take your time to do so. That is it for today. Take a moment if you have any questions to post your questions on Google Classroom if you have any. Thank you so much for joining me again. Once again, another math video. I'll see you next time. Ciao, ciao. I said, ciao, ciao.